Hi, guys, again. This is now chapter 6, and the title of this chapter is Security Protocols and the Defense of Depth Security Model. This is a continuation of from the previous chapter. In the previous chapter, we were talking about the network basics, and we discussed the basic components of networks as well as the protocol and standards. Now, in this chapter, we continue further and we will be discussing the different security protocols in addition to the defense of depth model. And we will also discuss the model itself and how it is related to the different security devices and the application of this model. So, at the end of this chapter, you should be able to understand the defense of the security model, and the second objective will be to understand the public key infrastructure, or the PKI standard, as part of the security protocols, as well as on the third objective will be the secure socket layer, or SSL, and transport layer security protocols. Now, as we all know, the 1990 or the mid-1990, by the introduction of the deployment of the internet worldwide, this of course has facilitated the availability and commerce and application. And of course, in order for these components, or the e-commerce and the web sites, or the communication to happen, we needed some kind of security. We needed to establish standards and protocols that could provide a common and interoperable platform suitable for exchanging information securely. So the idea is that you have a client and you have a server, and you are trying to establish a secured communication between the client and the server. Specifically with the internet, you have a web browser and you're trying to access a web-based application running on the server. So you need to make sure that the communication secure at the application layer, at the highest layer, which is at the hypertext transfer protocol layer, which is operating at the layer 7 of the OSI model. Now, by adopting some security at that layer, which is of course going to be the secure socket layer, this will facilitate the transmission of hypertext transfer protocol securely using the SSL standard, or the encryption standard, between the client and the server. Now, of course, in recent years, we have also indicated in chapter 3, we studied different security model, and we just highlighted one of the most important model, which is the security or defense of depth security model. But before that, we talked about the perimeter security model, and we said that this solution is not sufficient, given that emerging trends such as increased mobility, because we don't have a static information, we don't have a closed network, we have an open network, we have an open communication. Everybody try to communicate with each other. The internet is our shared platform. We have cloud computing and shared application services, and therefore the trend of securing at the perimeter or the boundary level was not sufficient, because there is a demand to open this boundary, to open this perimeter to the partners, to clients, to users across the community. That's why there was a demand for ability to have a remote access and remote connectivity, and to ensure that the resources or the organization data are being utilized in an effective way. Now we begin with the first topic of this chapter, which is the defense of depth security model. And this model really is one of the most important model that exists in terms of our environment. It is a kind of comprehensive model. This is fits or meeting the organizational goals, and by adopting certain critical processes that will support these goals. Now there is a figure 6-2. I have put some layers of control, and this graphical representation, it shows that the security is not just at the perimeter level. The security is at the yes, at the perimeter level, but it is at every component here at the information level, at the physical level. There should be some kind of standard or some kind of security implementation at the information level, at the physical security level, at the operating system security, at the network security, at the database security, application security, and the user security. So every layer we should have this type of security. Now, by acting so, we ensure that, even if one area is being threatened, but it's not going to affect the other areas, because the other areas are self-secured or independent. Now, most of the today's organizations typically have invested in a variety of devices as corresponds to the OSI model. They invest in firewalls at the perimeter, automated virus scanning technologies, physical security systems, spyware, adware detection software, automated or manual patch management, and other sophisticated network traffic monitoring and tracking tool. Some organizations, even they contracted with some kind of security providers and to do penetration testing. And so now, in terms of the defense of security, defense of depth security model, as can be illustrated from the next figure, which is figure 6-3. It consists of 5 different layers. The data is at the highest level, followed by the application, and then the host, then the internal network, and the perimeter level. And of course, we have then the physical security and policies and procedures as part of the overall defense of the security model. Now, identifying and justifying these types of technologies is of course, the IT manager's responsibility, and all managers that are involved in the security aspects or the trends in the organization. Now, if we want to map the different layers of the defense of this depth security model, which are the 5 layers, and to see what are the corresponding network devices or security devices that exist, and to identify what are the positive side, the pros and the cons for each. Now, if we begin with layer 1, which is the perimeter layer, this layer we discussed it back in chapter 2. And this perimeter layer, it's really very much related to web servers, mail servers, etc. Now, the device that we could have, which is at the border layer, we could implement or deploy the firewalls. We can employ virtual private network encryption, network-based antivirus to ensure that the virus are protected at the perimeter level. Now, the pros, that there's a lot of vendors, so there are many solutions here. It's of course the advantage is easy to implement. It's been around for many years, now at least talking about 15 years, and there are some disadvantages that hackers can easily penetrate it, even though you have all these kind of devices. But unfortunately, because there are many multiple point of failures that could exist in this setup. Now we move to the layer 2, which is in this case is the internal network layer that's mapped to the LAN WAN or the network layer of the OSI model. Okay, and in this case, usually the device that is being adopted, or the network device, security device, is the intrusion detection system in combination of vulnerability management system and network access control can be implemented to ensure that access to the resources is being restricted and control and authentication is there. Now the pros or the advantage, solution provide, of course, deep security, not easy to breach because we have an access control. Even the users can access the parameter, for example, but they need to have some kind of access control and security, or should be authenticated. Now the cons, of course, the IDS tend to report false alarms sometimes because the IDS capture a lot of data, and some solutions better for specific network devices are other than network as a whole. So still the IDS technology is not really at perfect shape yet. It requires still further improvement in this area. Now at layer number 3, it's the host security layer, where the host servers, individuals, computers, routers, etc. These are the layer 3, where we could provide some security at that layer by having host-based intrusion detection system and antivirus solution for the host. The pros available for this one is that we secure those devices. Solution provides good operational protection at the device level. The disadvantages or the cons is that it's time consuming to deploy and or to fine tune these devices. Now layer 4, which is the application layer. The application layer is very interesting layer. It's very much close to the encryption and cryptography that we have learned back in chapter 4. Now, for this layer, in order for us to ensure proper security, we need to utilize what we call public key interface or public key infrastructure, or PKI. And RSA as a security protocol is adopted in addition to the access control authentication. Now the pros or positivity here is that the encryption provides, of course, robust security. Okay, it's very secured environments. The disadvantages is that there is overhead involved. It's slow. It could be slower response due to the algorithm could take longer time in terms of encryption and having different entities involved in the process. Level 5, which is the data, the encryption on the data. Solution provides good security, but the cons depends on good organizational policies. So we need to have very good policies at the end and good execution of data guidelines, and in order to make sure that this is valid. The second topic for this chapter is we want to talk about now, which is some kind of security attributes related to layer number 4, which is the public key interface or the public key infrastructure standard. Now, the public key infrastructure, or PKI, provides all the components necessary for different types of users and entities to be able to communicate securely and in a predictable manner. PKI is actually made up of certain components. It's made up of all hardware, application, policies, services, users, and utilities. Okay. These components, they work together to allow the communication to take place using the public key cryptography and symmetric key. So it's utilizing both the combination of the public and the private key, in addition to the make sure that the digital signature and data encryption and integrity is preserved. the PKI environments entity is called the registration authority. So there are two major entities for the PKI. One of them is the registration authority that registers the user, and the other one is a certification authority, the certificate that provides the certificate to the user. So anybody wants to have a certificate, to have an access, he should request that from the registration authority and try to get that, and from the registration authority, who that in turn communicate with the certificate authority to get the certificate for that specific user, and that also coupled with the integration of public and private key encryption. There's a good example presented here about the Department of Motor Vehicles. So if you want to have a driver license, you need to have an ID to present it to the Department of Motor Vehicle before they give you the driver license. Once you are authenticated, then you need to pass the test. Once you pass the test, then you will be provided with a driver license. Now, you have been given the driver license. Now, when you go to anybody else or to anybody, you will be authenticated based on the driver license. Now, you will be authenticated not because of you, because of the third party, because of the Department of Motor Vehicles. So it depends on the third party. So the same concept applies here. Now, in PKI context, the the registration or the registry authority, the registration authority in this case is not the Department of Motor Vehicle or DMV. It is an RA in this case, and it will require proof of identity from from the person who's requesting the certificate, and will validate this information. So the RA will then advise the certificate authority, the agency, to generate a certificate for you, which is announced to the driver's license. Okay, so the CA will digitally sign the certificate and using its private key. This model is referred to as a third-party trust model. Now, public keys are components of the digital certificate, and in this way will be extracted for encryption purposes between the two parties. So the diagram here illustrates how the user goes to the registration authority requesting a digital certificate, and how the registration authority requests that and pass it to the certification authority in order to generate the certificate for the user. And once the certificate is issued and initiated, then it could be sent after that, after being signed by the certification authority to the user, and then the user can utilize that certificate in order to access different resources on the environment. So the implementation of the public key infrastructure for securing and encrypting data at the application layer of the defense of depth security model has gained popularity commercially, of course. Therefore, we will examine different standards and protocols in securing internet and business using PKI. There are different protocols that have been created around the PKI. There's the PKI-X, that is X.509 standard, and the PKC which is the public key cryptography standards, are the two main standards that have evolved over time to implement public key infrastructure on a practical level on the internet. They are based on, of course, an X.509, that is an international standard certificate standard, and establish complementary standards for implementing PKI. Now here, as our third topic, after we discussed the defense of depth security model and we looked at the application layer by looking at the public key infrastructure, now we can also discuss the method of communication and how it is going to be, and how the path or the channel between the client and the server could be encrypted, and using, of course, the secured or the secure socket layer and the new one, which is the transport layer security. Now, these provide the most important means of interacting with the PKI and certificate. SSLL, which is the secure socket layer, was introduced by Netscape originally as a means of providing secure connections for web transfer between between the client and the server for encryption. Now, SSL and TLS provide secure connection between the client and the server. They are cryptographic in nature, okay, and they provide data integrity, or they ensure data integrity security over network by encrypting network connection at that transport layer. Now, of course, SSL and TLS, they utilize asymmetric and symmetric, so they use both the public key and the private key encryption mechanism to set up for the transfer. And of course, this is where the HTTP also, once it's used the SSL, it becomes the HTTPS, or hypertext transfer protocol, that is secure. And the following diagram shows you the session and the handshaking session between a client and server, how it is being initiated, and it will give you an overview how this is possible. And the last diagram is an interesting one. It shows the communication between the client and the server, where the client is the browser sends a message to the server requesting a secure session from the web server. Then the web server responds by sending over its server certificate. So it sends a certificate containing information about the site, certificate authority, etc., and the public key. Now, after the browser or the client verifies the certificate, it sends a one-time session key encrypted with the server's public key, and the server decrypts now that one-time session key using its private. This kind of handshaking method improve the security and ensure the integrity of the communication between the client and server. Thank you.